Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
Yo, 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 all y'alls, and welcome to JavaScript Jabber with your guest host today, AJ ONeal, and your guest, the most important guy on the show, Kyle Simpson.
Hello, everyone.
We also have with us our usual from Nashville, but not necessarily always in Nashville, Aimee Knight.
Hello, yep, in Nashville today.
And our Jedi Master, Joe Eames.
Hey, everybody.
So, we've got Kyle on the show to talk about functional programming and functional-light programming. Huh?
Yeah. So, hello, everyone. Thanks for listening in. So, as mentioned, my name's Kyle Simpson. Most people know me online as Getify, and I'm probably most well known for a series of books I wrote called You Don't Know JS, but we're here actually to talk about my latest book, which is not part of the You Don't Know JS book series, and that was actually heartbreaking to a few people because I regularly get questions like, when's the next book coming out? When's the next book? And let me just put the issue to rest. That book series is done. There may be a second edition because there's a bunch of updates that need to happen, but the 6 books of that series is done. And so my functional book that we're going to talk about today is a whole separate book all unto itself. And that book is called Functional-Light JavaScript. And it is essentially from the same spirit as the You Don't Know JS books, which is I have this topic that I want to learn about, and I document that journey by writing a book. And that's what I did. I wanted to learn what it would take to pragmatically weave the ideas and concepts, the core principles of functional programming into what is otherwise a recognizable JavaScript program. Are those two compatible? And can you do so without learning lots of sophisticated notation and terminology like category theory and things like that? Is there some pragmatic way to do it? And what I arrived at is what I call functional light programming, which I guess best described would be...
Hold on 2 seconds. First of all, just give us a refresher on what functional programming means, because that's a word that we throw around all the time on the show, and we could probably stand to review it once more before we go into functional light to give us some good contrast. So what does functional programming mean to you?
That's a really good question, and actually I would say probably everybody could stand to review that once every couple of months, because it's easy to get messed up on that.
Is that because the community's changing the definition that often, or it's becoming more sophisticated?
Is it like REST, in that everybody thinks that they know it, and then the person who creates it says that everybody else misunderstands it? Is it like that?
It's maybe a little bit of each of those and a few other things. So I'll certainly share some perspectives on what's happening. It is undeniable that right now, functional programming as a set of principles and concepts is experiencing somewhat of a renaissance. It is a re-awakening. It is people paying attention to it that have never really paid attention to it before. Whole areas of software developer discipline that are starting to say, wow, there's this functional programming thing. But as with most really good ideas, kind of like with Agile, where you could line up 10 different teams and ask that all claim to be Agile and ask them what Agile means, and you get 11 different definitions for it. It's kind of the same way that functional means, or people pull bits and pieces of functional and build their whole meaning for that term based on that. So it's not really incompatible, but what you have is a lot of disparate, different, smaller perspectives on functional programming.
So,
and in that sense, Functional-Light would kind of fit a similar.
You said this was a renaissance. Can you kind of give us a little bit of back history of functional programming and why you would call this a renaissance? Is it that we're moving into a new age, or is it a reemergence? Like,
I think it's a reemergence, and I have some thoughts on why that's happening, but I'm certainly not an authority on that. But let me back up and sort of address the original question, which is, what exactly is functional programming? My perspective on that goes back to some of the earliest days of my exposure to programming, which is over 2 decades ago. When I heard the term functional programming, and I don't even know where, but I heard it or read it somewhere, and that would be pre-internet, really, actually. Hearing that term and hearing the word function in the word functional, the natural inclination is, oh, well, if I use functions, therefore I am doing functional programming. And that naive approach or perspective is both completely true and totally missing the point. And I want to explain what I mean by that. It is entirely true that functional programming is just programming with functions. What's missing is that we have lost what programmers in the early 60s and 70s would have said is the real definition for what a function is. So actually, to define functional programming, you have to define what is a function. And it is not what many of our conceptions would be, is simply a collection of operations to do some task. That's what we think of when we think of function, and JavaScript gives us the function keyword, although nobody uses it anymore because everybody loves arrow, but we have the idea of creating a function, and we can put whatever statements we want inside of that function, so therefore, that's what makes it a function. That's where we got off track, is when we started putting collections of operations arbitrarily together with some name, and then we called that a function because that betrays the very core essence. And it's actually not an essence that was defined by computer scientists, but prior to computer science, it was defined by mathematicians. So to set the record straight, a function is not simply a collection of operations. A function is an operation or operations specifically that takes some kind of input or inputs, using those inputs, compute some output. That's what a function is. Now, in the course of doing that, it could have one operation. It could simply be like double this number. That's a function. Or it could be much more sophisticated, like run through this whole loop and calculate the mean average on all of these things, inputs or whatever. But either way, the idea is that you want to map inputs to outputs. That's what a mathematician originally defined a function as, I don't even know how many hundreds of years ago. And when computer science came along, based upon math theory, they said the same thing. A function is that in symbolic form. That's what in our code, that's what a function should be. So functional programming then is trying to wire up your program to have as many of those as possible. That really is, it really is not actually more complex than that. It is to say, I want to organize all of the computations and the flow of data in my programs as a series of truly defined functions. And the next question that then comes is, then how can I do other things, like, for example, print something to the page so you can see it, if I can't consider that as a computation of an input to an output? Well, what we're talking about with that big old umbrella or bag of other things is called side effects. So if you take a step back and ask, what is a side effect? A side effect is anything indirectly happening as a result of any operation. A direct output and a direct input are what we know of as arguments and return values. Anything that's not an argument or a return value is indirect. It's either an indirect input or an indirect output, and indirect inputs and outputs are what we call side effects. So printing to the screen, changing the DOM, making an AJAX request, generating a random number, pulling a timestamp, writing to the file system, and 1,000 million other things. Those are all side effects. And those are all not part of the definition of a function.
You said pulling a timestamp. That one stands out to me. Could you explain that and why that's a side effect?
I can, but we have to build up a few other things to fully explain it. Okay. So let me come back to that. It's a really good question, but let me come back to that. So what I'm getting at here is that all of those things, if we lump all those things together and we call those side effects, you typically would hear or infer from a functional programmer that side effects are bad. Side effects are to be avoided. But I don't think that really captures the spirit of functional programming. I think it is to say that A, side effects should be minimized, and B, side effects should be intentional and explicit. That's what we really mean. So you cannot have a program that does not have side effects. In fact, a program with no side effects would be indistinguishable from the absence of that program. You couldn't prove that it existed or that it ran. So everybody knows that side effects are a necessary requirement to have anything non-trivial that you do as an application. Writing, for example, the JavaScript program that just loops over something and adds up a number, if you ran that program and it had no input and no output, you couldn't prove that it actually ran. As a matter of fact, if you really think philosophically about it, the heat produced by the CPU while running that program is a side effect on the system. So it's impossible to have a side effect-free program. What a functional programmer wants is a program that is very intentional about its side effects, that is minimal in them, meaning we don't need to do side effects everywhere just because we can. We should only do them where strictly necessary, and we should be very careful and reasoned and intentional about how we do them. And that is the heart of functional programming. Make as much of it about the pure, what we mean by a pure function is meaning the input computed to output. Make as much of it that as possible. And wherever possible that we need side effects to do inputs and outputs, collect those together, be very intentional about them rather than non-obvious.
So I wanted to mention something too for like clarification for people who may be a little bit, newer to this. I think the first introduction I had to functional programming was actually refactoring, kind of like what you're saying, trying to push the side effects to the edge of your program so that the stuff, like the guts of it, can be easily tested with these like pure functions that, given the same input, always produce the same output and don't, affect anything in the outside world. So I just kind of wanted to make that clarification. In JavaScript, it's not a purely functional language, but it makes doing that relatively easy.
I'm glad you bring up refactoring, Aimee, because that is one of the big themes of the book, which is to suggest that, at least as far as I have come to terms with functional programming, and I am still on a journey and still learning. I'm not a card-carrying member of the Functional Programming Cool Kids Club. I'm just learning and trying to do it, and probably a lot of what I have to say is maybe even a little heretical from the truly those that are truly enlightened with functional programming. But what I really think has emerged as a theme from the book and my perspective on it is that I can't write a functional program from scratch, really. For me, as a JavaScript programmer, I write a JavaScript program and then refactor it to be more functional. It is not the case that I set out with any project and make all the right decisions from the very first moment and just perfectly lay out all my monads and all that other stuff, right? Like, that's not how it works for me. How it works for me is I still think in pragmatic JavaScript imperative terms, and then I take steps to refactor and to improve. And I think that effort to do so is most important for kind of two big reasons. The one big reason that any functional programmer will tell you is that if you take the steps to be diligent and disciplined about applying functional principles to your code, what you do is reduce the surface area of the program that can create bugs. You make more of the program based on proven mathematical principles. And we don't need to go back and test or figure out whether 1 + 1 = 2. That's a math principle that pretty much everybody just takes for granted. But it's the same concept. If we know that there are these things that work a certain way and work a certain way together, if we can make more of our program based upon those kinds of Legos, then that's less of our program that we need to be concerned about being the problem when a problem arises. I don't need to figure out if the problem is in the 1 + 1 part because I know that works. It's in this other stuff. So a functional programmer would first and foremost say, I think, functional programming focuses on using as much of the proven stuff as we can so that our brain is freed up to think about the unproven business logic parts more freely. But I think a equal or more important narrative is that in doing that to create more reliable, provable, verifiable code, that sort of thing, we also create more readable code. And that's where my passion is to use functional programming to more clearly articulate, more explicitly oftentimes articulate the ideas that I have. Where imperative code doesn't do that much, it distracts the reader to think about how to compute the sum, whereas declarative functional programming says, it doesn't matter how the sum is created, this is why we want the sum, and this is what we're going to do with it. That's a more readable narrative style of coding. And so I think those are the two big themes that I try to get across in the book. Code that you can rely upon, and code that can be more readable and better communicate. So with that, I wanted to get back to a question that was asked a little moment ago, kind of a tactical question. How is pulling a timestamp a side effect? Is that a bad thing? Well, one of the things that we want out of a functional program is we want to be able to look at a line of code and know what that line of code is going to do. We want to be able to mentally compute that. But we don't want to have to do unnecessary work to do so. So if I'm on line 5,000 of my program and I'm looking at this line and I'm trying to figure out what it's doing, if that line of code can be understood and mentally computed in isolation, it's far less work than if I have to run the entire program in my head, all other 4,999 lines, before I get to line 5,000. That would be a lot more work. And what we would like is for the reader of our code, which could be our future selves, to do less work to understand a line of code. Let's just let all the other stuff stay independent. Let's focus only on this line. You can only achieve that if that line of code is what we call a pure function, if it's a function call that is pure, that is not relying on these side effects. So there are various ways that we could define a side effect. In a very base sense, a side effect is any function relying upon any state of the program or relying or modifying any state of the program outside of itself. That's one way of thinking about it. But it turns out that definition, while not wrong, is incomplete. My metaphor for this is like looking at a Rubik's Cube. If you're trying to solve the Rubik's Cube and you only look at one of the 6 sides, you've gotten some of the truth. It's not wrong, but it's not enough to solve the puzzle. There's other angles that we need to look at here. And so beyond just, does my function use something or modify something outside of itself, we also have to ask, and this is where we really get to the most canonical definition of function purity. Can a function call, when made, does it have a property to it that we refer to as referential transparency? I know that's like throwing out a fancy term, but let me just say pragmatically what that means.
Is it the same thing as transclusion?
I don't even know what transclusion is, so I don't know. So what does it mean for a function call to have referential transparency? It's important to note that it's the call itself, at least in JavaScript, it is the call itself that either is referentially transparent or not. It's not the function that is, it's the call to the function. So we're focusing on this function call, and for it to be referentially transparent, what that means is that we could replace the function call with its return value and not affect any of the rest of the program. It's not actually that sophisticated of a concept. If you see foo parenthesis 3, and that returns you the value 12, could we replace the expression foo of 3 with the value 12, and the rest of the program would function identically? If that is the case, then what we have is a referentially transparent function call. We have a function call that is independent of any other state in the program. It is a pure function. Now, getting back finally to the question of the timestamp, the reason why a timestamp doesn't qualify, the reason why it's in the bucket of side effects, is that it relies upon a state of the system outside of itself that is not repeatable. We cannot have a function that relies upon a timestamp and know that every time we call it, we're going to get the same output. And if we don't know that, then we can't assume that we can replace it as referential transparency would assert. So that's why random numbers and timestamps and network calls and file system operations and DOM operations and all of those other things, they don't qualify as pure function operations because they would violate the principle of referential transparency.
So
hopefully that helps to answer that original question, though.
Does that mean that referential transparency I'm saying that's what the term is, right? It's like such a long term. I'm afraid I'm missing a word in there.
Just use pure function. Maybe that's better.
Okay.
Just a pure function call.
Okay, so referential transparency or pure function call really is tantamount to having no side effect, or basically it is also the same thing as the core of functional programming. Yes?
Yes. It's tempting. Every time I teach a core principle, and there are multiples in functional programming, there's a temptation on my part, and I think other parts, to say, well, this is the one thing that if you don't have this, you don't have anything else, right? Because I can say that about compositional data flow. I can say that about functional purity. I can say that about declarative style coding. I can say it about point free. I can say it about all these different things. But it really, really, really is true that if you don't understand the necessity to have as much of your program as possible composed of pure functions with referential transparency, if you don't get that and why that would be useful, both from a debugging standpoint, like I can trust my code, and also from a readability standpoint, it's easier for me to compute mentally.
Testing.
If you don't get that, none of the rest of functional programming really works.
And testing too.
Sure. Go ahead.
Oh, sorry. Well, and then the other thing I wanted to say, kind of piggybacking off of, what Joe is saying and how, even you, Kyle, talking about referential transparency. So I gave a talk a couple of weeks ago at a functional programming conference in Knoxville, and kind of like the basis of my talk was, I think that there are a lot of concepts, especially in JavaScript, like a lot of functional concepts that you can apply in JavaScript, and a lot of newer developers are just newer to functional programming. It can be a very intimidating space to enter. And I think, we use like these big terms, but really, if you break them down, they're very understandable, a lot of them, and they make the code, much easier to understand and read, like you're saying. So I don't know. All that to say, I just encourage more people to not be put off by, the topics or just functional programming in general, because sometimes it seems very academic, or, there's a lot of, it relies heavily on math, and that can scare some people away.
It's not a small detail what you're pointing out, Aimee. I think it is maybe one of the biggest problems in the whole discipline is the perspective that you get when you first arrive at a traditional description of functional programming that starts using fancy terms, starts using confusing or less familiar notation, things like that. That's my journey. And I know many, many, many other people have raised their hand along the way and said, that's my journey too, which is that you come up face to face with that. And I describe this in the beginning of the book, like, for those that are listening that maybe know about rock climbing, I use that. I'm not actually a rock climber, but whatever, I'm going to use that as the metaphor. It's kind of like arriving at the face of a nearly vertical cliff. And you can see up on the top of this mountain and even hear people up there saying, this is so awesome. You should totally climb this mountain. And you be completely motivated to want to climb the mountain. You're like, yes, I want to go see what's up there. And it's awesome. And I can see that people have done it and they have benefited from it. Okay, how do I climb? And to get the response from the people up on top, which is to say, well, you see that pile of equipment over there, just use that to climb up. Because for them who are already experienced climbers, it is, and it's not as a criticism of them, but it is far too easy for them to forget what it was like for them when they didn't know what a rope was, or they didn't know what a carabiner was. They didn't know what those things were. Somebody had to literally say, no, you feed the rope through the carabiner and you loop it like this. That's so completely, for an experienced climber, that's so completely obvious now that they've forgotten what it's like. So I liken that to functional programmers who have long since gotten so familiar with the concepts of functional programming that they can throw around notation and terminology like we would talk about ropes and carabiners. And they say, well, look, if you just loop the loop around here and the carabiner and this, well, then you can do this amazing climb. And they've forgotten that I don't even know what a carabiner is. And so my approach to the Functional-Light book, I start out with that metaphor in the beginning because my approach to the book is I really wanted to learn functional programming. I desperately wanted to because I believed in its benefits. But I kept trying all the usual paths to do so, reading books, going to conference talks, reading blog posts about it. And I kept coming face smacking into the cliff and not knowing how to climb. And what I wanted to do was say, I think there's a way to climb this mountain without understanding all of that complex stuff. It starts with figuring out how to loop the rope through the carabiner. So I'm going to talk to you about ropes and carabiners. We're not going to talk about all the crazy stuff like category theory and all that. We're just going to focus on the simple pragmatic principles. Here's how to take your first step up the cliff. Here's the next step up the cliff. I basically end the book at about what most functional books start as their chapter 1. I feel like it's not really like an intro to functional programming, but it's diving into all that stuff that many functional programmers just assume that a reader already understands. I didn't, and it took me years to learn, and so I just documented the learning of that. And I furthermore said, by the way, learning the fullness of functional programming is a worthy task if you want to, but it's okay to just stop right here with what I call Functional-Light. You can get enough benefit out of your JavaScript program just with these principles that you don't ever have to go into that much more sophisticated approach to programming. Not that you shouldn't. Maybe you should. Maybe it makes sense. But I wanted to create a plateau, if you will, for you to arrive at, that you can have a sense of achievement. This is something that I've made significant improvement to my JavaScript programs, but I didn't have to go learn a whole new language. I didn't have to go get a math degree to do it. I just learned how to use the ropes and the carabiners, and I climbed a little bit up the mountain. That was my goal with the book, and I hope that that's what people get from reading it.
When you start a new project, typically you need things like a domain name, hosting, things like that. When I choose hosting, I pick mine for the options it gives. I like to know what I'm getting and set things up just how I like them. This is why, for your projects, you should check out Linode. Linode servers feature native SSD storage, a 40 gigabyte network, and Intel E5 processors. That's all the power you need to run VMs under full control, or Docker containers, who doesn't love that, encrypted disks, and VPNs. Plus, they have 10 data centers across the world and add-ons like backups, Node Balancer, and Longview to help you control your server costs. They also offer block storage for your static files, and you can get started with a $20 credit if you use the code JavaScript Jabber 2018. That credit is good for 4 months on their 1 gigabyte server. That's a lot of time to try them out and see if they're the right fit for you. That code again is JavaScript Jabber 2018. Also, if you're interested in working for Linode, they're hiring. Head to linode.com/careers to see their available positions.
All right, I've got a two-part question going back to something that you said about surface area.
Okay.
Right. But before that, I want to ask a very quick question, which is that I noticed that your book is available on Kindle. Is it normally coding books are not something you would get on Kindle unless you're going to read them on your computer, right? So would you say the same thing about this book? Is there enough code in there that, you don't want to be reading this on your phone?
There's a ton of code in this book. Maybe more so even than any other book I've written. There's a lot of code. It's a longer book than I've written before. It's almost 390 pages. So it's a pretty significant book that you don't want to. The word light in the title might think, oh, like easy, simple intro. I don't mean it that way. I mean light in contrast to having to go learn Haskell before you can write one line of code. That's what I mean by light. But I wanted to make the book available in as many different formats as possible. So it's available digitally. You can purchase it from LeanPub. You can purchase it from Amazon, which is where you get it on Kindle. It's also available in print. So if you're one that likes to have the paper and do the highlighting, you can buy it in print. And just like all my other books, you can also read it for free on GitHub. So I tried to make it available in all those different formats. I personally could not imagine reading all of that code on a phone. but maybe that works for some people. So I'm not going to judge how people like to consume the material.
Gotcha. Okay, so I want to circle this back around to something that I think is, a fairly popular topic in the today's world of frameworks, which is presentational or smart/dumb components.
Okay.
So I'd like to discuss how this plays into those concepts first, and then I got 55 questions, but let's just start with that one.
Okay. It's a broad enough question that I need to clarify. Do you mean like what people mean when they talk about putting a React component on the page, like a calendar?
Yeah, React is definitely the place where this is discussed most often. So let's say React when they say presentational, and then I can't remember the name of the other type of. Sometimes I hear the term smart and dumb components, but there's the presentational component. What's the other kind?
I don't know, since I'm not
Aimee,
a React developer.
You're the React developer here.
Sorry, I was looking at something else.
Aimee's muted. It's presentational components, and what's the other kind of component in React?
Pure component, like a pure function?
Yeah, isn't that presentational considered pure? Anyway.
I don't know what the lingo is for that.
Yeah, all right. Well, forget about what the other term is, but you know what I'm talking about, and I think listeners will get it. So let's move forward.
Okay, so I will caveat this by saying I'm not a React developer, so everything that I'm about to postulate about React is subject to, I don't actually know what I'm talking about, but
hey,
I do know some things about.
Can I interrupt really quick?
Yes.
It's container components was the other term I was looking for.
There you go. Okay, great.
It's presentational container. Sorry about that.
So what I know about React is that React is in itself just trying to solve the question of how do we compose the different bits and pieces that make up the UI. In other words, it's the render function. It's a rendering layer. It's not trying to solve the architecture of your whole app. There are lots of other libraries within the React ecosystem that solve that. There's data flow things. There's routers and all that other stuff, right? So there's lots of other pieces. But when we talk just about React, it's trying to get all these bits and pieces together to make up a UI. If you try to ask, what does that mean to a functional programmer? You have to think in terms of layers. Because if we're at the highest level layer, the act of taking some markup or some DOM operations that produce divs and paragraphs or whatever, that code, when it runs against the DOM, is totally side effecty. That is not pure at all. That is very much creating side effects. But as I said before, functional programmers don't say side effects are absolute evil. They say that side effects should be minimized and contained and be explicit and intentional rather than just sort of accidental. So what we're really doing in something like React is we're creating these mechanisms by which we can shuffle off the problem of side effects to a specific part of the workflow. In this case, the very last step. In other words, every other step up to that point, or if you wanted to visualize this as layers of a cake, if we're starting at the bottom of the cake and working our way up through the layers, all of these layers are taking one input, which might be the state of our system, and producing another output, which is the new state of the system. And that may be take the input state and produce me some markup. It might be produce me the code that's going to generate the DOM elements or whatever. But I'm going to build my component or whatever it's going to build up through all of these layers. And it's only the last layer where we hand that newly computed state off to the side effector, which is render this to the DOM. And I know React does it through a virtual DOM first and then whatever. But that is the idea of functional programming being played out in the React ecosystem, is all of those other pieces could have been side effecty. You could have been peppering in different things into the DOM at each of those different layers. But we all know that's why, we have spaghetti code in our front end. We all know that's the jQuery style of, spaghetti kind of code. And that's what we want to avoid. So what React did, without even really calling it functional programming, without even packaging it as if you were writing a functional program, they took one of those most important essences and said, what you need to do is compute an input and an output and compute an input and output and so on. That's what Redux does with the data flow when they use reducers. I mean, that is literally taking an input and computing the new output. So all of these different parts of their system are an embodiment of those principles from functional programming. The component idea, meaning this component is separate from that one. Now, that's a different question entirely, because that's not really about the isolation of side effects as much as it may seem that way. My perspective is that that is much more an architectural question rather than a functional programming question. It doesn't mean that it's not interesting. It just means it's not really something that I would say is embodying functional programming.
So this kind of brings me to a question that I have that I wanted to ask you, because I feel like you have, I don't know, you're very like reasonable, I think, in a lot of your definitions of things and, you know, how you go about deciding whether or not to use something. So as we're talking about like presentational and container components, I feel like a lot of times, like, you know, this is an opinion, but sometimes you can abstract something too far where you kind of now like overcompensated and it's not easy to understand what it's doing because it has become so abstract. And I know like even us talking about this is probably a little hand wavy, but do you have any like guiding principles or any wisdom as to when it may have gone too far?
It's a fantastic question. One that I address directly and indirectly a number of times throughout the book. I'll say that my answer to that question has two sides that are opposed to each other. It is never the case that one side is right and the other's wrong, but that the truth fits somewhere in the middle between them, and that the tension between the two is how you figure out the truth. So I'll say that I'll make the observation that our comfort level as developers, what we're really talking about when we talk about like a comfort level in understanding something, is given a fresh set of eyes, which is either a brand new developer or somebody that's not looked at the code in a while, like a few weeks, even if they wrote it, right? But a fresh set of eyes, can they reconstruct in the reading of this code all of the thoughts that went into the writing of the code? That's really what we're talking about with comfort level. When we create abstractions, we hope that what we're doing is we're making that process easier to do. We hope that we are creating semantic boundaries. And by semantic boundary, I mean, here's one thing on the left side, and here's another thing on the right-hand side. Both of those two things are important, but neither one of those two things has to be thought of at the same time as the other. They can be thought of independently. And the way I'm going to make it so that I can think about them independently is insert some kind of conceptual semantic boundary between them. The way that often looks is we call it a function name. If I take how to compute the sum and I put it in a function and I call that function compute sum as a name is the semantic boundary between how I compute it and what I do with the result of the computation. Those are the two sides, the left and the right. Those are both important. But when we conflate the two together, it gets really hard to understand. And so creating abstraction is really about creating semantic boundaries where you separate two things. So a programmer is really trying to do that well, trying to look at two things that are inextricably wound together in a complex way and tease those two apart so that I can think about them independently and put some semantic boundary, even something as simple as a function name, in between the two of them. That way I can sit on either side of that boundary and understand independently. Now, what we're hoping, especially in functional programming, is that we do that well. And later on, when somebody comes along, they see a series of boundaries between stuff, and they're like, all right, I get this part. I'm only going to think about this. And then I'll jump over the wall and I'll think about this. And then I'll jump over another wall and think about that. It is absolutely the case that those semantic boundaries are only readable or understandable if you have familiarity with the process in which they were created. In other words, you could not possibly think that you could take a non-functional programmer and show them a functional program and just magically they'll understand it. That is not how it works. Maybe that's what we kind of idealize or romanticize in our minds, but that's not how it works. So what we really have to do is we really have to say, you have to be familiar with a thing for it to be readable and understandable. You have to be familiar with a pattern or a process that creates those boundaries. So I can't just take any old developer on my team and give them some of my functional code and hope that they're going to understand it. That's not realistic. They're going to have to learn some stuff. So herein we have the tension. I want to create more readable and understandable code. I mean, I hope that's what everybody's goal is when they're writing code. That's what I'm trying to evangelize. So I want to do that. Okay, we agree on that. How am I going to do it? Well, I'm going to use these patterns and practices. Developer B says, I don't know what any of those are, so you just threw a bunch of words at me that don't make sense. Okay, Developer B, what I want you to do is learn these principles, and then all of a sudden, magically, you can read my code. So now everybody's happy because both Developer A and Developer B have a shared language. I don't mean computer language. I mean, it's almost a DSL. They have a shared language upon which they can communicate. And that language is how those abstractions came about. Well, that's good. We want everybody to be learning, and they're going to have to be learning. But here's the tension, because at any given level, if you don't have familiarity of the thing, if somebody above you in that level of understanding uses something, all of a sudden you're lost again. So how do we decide for a project where we draw the line? Where is too much? And that is a really hard question with no perfect answer. I can't tell any team, this is the thing. You do this and it's great. You do this and it's not great. I can't do that. What I have to say is that at any given moment, you want to ask, if I apply this refactoring to this piece of code, will it improve the readability of that code or not? It improves it for me, but will it improve it for the other people that need to read it? Yeah. If the answer is yes, then you should do it. If the answer is no, this is the tough part, because it might just be that you shouldn't do it, or it might be that everybody needs to learn the boundary better so that you can do it. And I can't tell anybody which one is the right answer, but that's the tension. And I address that many, many times throughout the book. I remind the reader, here's how to do something. Here's how to refactor with point free, but always take a step back and say, did that help or did it hurt? And even if it hurt, maybe that hurt is a good thing for me to learn better and for other people on my team to learn better.
That's so wise, because I think a lot of times we, as developers, we want to have less code, and we come up with sometimes clever solutions because it's deleting code, but it's not always more readable.
But you always have to come back to readable is in the eye of the reader. It's in the eye of the beholder. And nothing is ever objectively readable. Yes. Everything requires an investment of time to learn a thing before you can say that you're familiar enough to read it. Yeah. And so it's really figuring out, where do we draw those lines? We should all be learning, but should we require everybody to be so confused all the time that we never get any code ship? That's not going to be good either.
It makes me think, so a couple weeks back, I had a pick that was talking about what does readable code mean? I'll try to find it. And it was basically, be careful when you just say, this code is not readable. Make sure you have an understanding. A lot of times we will that's kind of like a cop-out answer when it's really just our understanding is missing and we need to level up in some areas.
So unfortunately, I have to run in a few minutes. So I want to get any more last things that you want to squeeze into people's minds before we end. What are the important things you need to say before we wrap up?
I'm going to leave everybody with a violation of what I said at the beginning. I said, I'm trying to do functional programming, but not use fancy terms. I want to leave everybody with a very quick little nutshell definition of what a monad is, because that's super intimidating, and it feels like I'll never get it right. And I don't even fully understand all that it means, but I want to, the book ends, there's an appendix B, that talks about monads. It ends where many FP books start. But a monad is really just a data structure. It's a way to take a piece of data and create a defined set of behavior for that data, so that if I have this monad and this monad, there's a specific way that those two pieces of data will interact. That's really all a monad is. If you recognize the value of having data structures in your programs, if you start doing functional programming, you're going to at some point say, maybe I want something a little bit more intelligent than just an object or an array. Maybe I want to have some kind of logic or rules for how that data behaves. And that's what monads give you. They give you a mathematically proven way to define behavior around your data. So hopefully that, maybe helps people. That's where you end up at the end of the book. You get to the ability to understand something like that, and maybe use something like a monad in a program.
Awesome. So if people want to get in touch with you and learn more, you are Gitify in all the places, Twitter and whatnot. What other ways might they reach out to you or become abreast of the goings-on in your world?
I would say that's pretty much it. I'm Getify, which is Getify. I'm Getify on Twitter. GitHub, that's my Gmail. Basically, any place online that matters, you're going to find me as Getify. So I put all that out there because I encourage people, if you're listening and you have questions or feedback, or if I said something that was radically, totally wrong and I need to learn it better, I hope you'll just, reach out, give me that feedback, because I'm on a continual learning process and I'm just trying to inspire others to keep doing the same.
Awesome. Well, then let's move on into picks.
For you, the listeners of JavaScript Jabber, Lootcrate is offering an opportunity to save 10% on any new subscription at lootcrate.com. Just enter the promo code BRIDGE10 for 10% savings. Lootcrate is one of my favorite things. Every month I get a box in the mail, costs less than $20, and it comes with all kinds of goodies. I have stuff from, just looking at my shelf, Batman, Spider-Man, Ninja Turtles, Back to the Future, Lord of the Rings, Star Wars, and much, much more. So if you're a geek, a gamer, anything like that, and you want cool stuff to put around your office, cool t-shirts, comic books, etc., then definitely check out Lootcrate. To save 10% on your new subscription, go to lootcrate.com/Ruby. Again, that's lootcrate.com/Ruby to save 10% on any new subscription. Enter the promo code BRIDGE10 for 10% savings.
Does anybody want to start us off?
I can go.
Go.
So the first one, I'm going to re-pick one that I picked, I think it was like back in January, called What Does Code Readability Mean? Based on what we were just talking about. So I'll drop a link to that in the show notes. The other thing I want to pick is it's Functional Knocks on Twitter. I will make sure that I have the Twitter handle in our show notes as well. But that is the group that organizes the Slam to Squared conference that I spoke at a couple weeks ago. And it was a small conference, but it was incredible. It was one of my favorite conferences I've ever been to. So that is going to be my second pick. And then my third one, I want to pick another podcast that I discovered called HTTP 203. So I'm not sure when this comes out, but I'm officially now a GDE. So I have been listening to this podcast and learning a lot of just, web fundamental stuff. And I don't know. It's not in you can't find it in your normal podcast app, but you can go to the URL and listen to it from there. So that's it for me.
Joe?
Yeah, so I got two picks. The first one is a book that I've been reading called Barking Up the Wrong Tree. And I got to say it was really good when I first started out, but when I got to the last chapter, it got to be amazing. Just an absolutely amazing book. And maybe it was just because it talked about exactly what I needed to know about right now, what's really on my mind in my life. I'm not sure, but I loved it, thought it was amazing. So I highly recommend it, Barking Up the Wrong Tree. And then the other pick that I want to have is kind of a weird, sort of almost self-serving pick. I taught a workshop on testing Angular. And rather than picking my workshop, I kind of want to talk about the fact that it was a really large workshop with 100 and some odd people, and it was great. I had an absolutely fantastic time giving the workshop, and there were so many people. There was a lot of really good interactive feedback. So I kind of want to just, rather than picking that specific workshop, pick workshops in general as a way to learn something. There's a ton of great ways to learn things. Books, online courses, workshops are just one of the many ways, but all of them have their valuable aspects to them. And workshop, I just was absolutely amazed and have really enjoyed teaching this workshop. But I learned a ton, and I think that the people who attended it too. So workshops are another great way to learn something. Those are my picks.
All right, Kyle, go ahead.
All right, so I have three quick picks. The first one is a topic that's in the news a lot lately, which is the European Union's new data privacy thing called GDPR, the General Data Protection Regulations. I kind of had been hoping or thinking, oh, I'm a non-European country, I don't need to worry about all of that nonsense. But it turns out actually everybody in the world needs to be thinking about that. And I think there's a lot of misinformation out there, but I found one particular blog post written by a UK law firm focused specifically on helping startups figure out, even if you're not a UK company, what do you need to know about GDPR? What does that mean to you? And so it's called the Startup's Guide to the GDPR. We'll include the link to that blog post if you don't find it via Google. But I found that to be a particularly good and enlightening one. It's also maddening to think that we probably should have been talking about this for like the last 2 years, and we're just now talking about it less than a month before it goes into effect. But it's something that needs to get talked about more. Second pick would be there is a new online school that is starting up specifically to teach developers. Basically, best kind of student would be somebody that just comes out of, for example, a coding school. Teach developers with that skill set how to get into blockchain and crypto. And I have been helping build out the curriculum for it. The name of this school is called Hatch, as in an egg hatching. Their website is hatchcrypto.io. If you have been thinking about or wondering how to get into crypto and blockchain and stuff like that, this is a free online program that then once you graduate the program, they help you get a job in that space. So it's pretty awesome. If you're curious, go check out their website. And the third one is that I am once again privileged to serve as the co-chair for the Fluent Conference. And Fluent Conference is in full effect. We are going to be running the conference June 11th through the 14th. So a little over a month from now. There's still lots of tickets available, tons of amazing talks, some really great training workshops that you should consider. And there are still some good pricing deadlines available, discounts. If you follow various different people on social media, you can dig up even discounts for them. But you should definitely come be part of the Fluent and Velocity Conference in San Jose next month. So those are my 3 picks.
Awesome. Well, thank you so much. And just real quick, mine is IKEA, because who would have thought that it all began with a god named Thor and some guys with a plan for a furniture store, but it did. That's how the West was won, or Europe or something. I don't know. I got a desk that I mixed and matched the Bacant tabletop with the Skarska sit-stand desk. It's got a crank on it that goes up and down because the tabletop looks a lot better than the default one that comes with it. It's got rounded corners, so I just drilled some holes and made it fit perfectly, and you could never tell that they don't go together. And that is my pick. With that, thank you all for coming on the show. Thank you especially, Kyle. Really appreciated your thoughts on functional programming. And I know Joe would love to hear more about that. I think we all would. But Joe particularly is sad we have to end a little bit earlier. But thank you all for coming, and have a great, wonderful day.
Thank you very much for having me.
It was great. I'm sure we'll have you on again. Adios.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.